motor stopped working.
Oh, yeah, it did. Wait, why isn't the land moving? I don't know how to swim, Lindsay. What are we going to do?
Aaron, calm down. We have an emergency tunnel.
Oh, thank God.
Oh no.
Don't worry. I'll call 911. Oh, drat, I don't have service. There's no one out here to save us. Lindsay, we're gonna die.
Man, we might be here for a while. Do we have any food or water?
All I have is this bottle of wine.
Well, I'm 17, so...
Well, do we have anything else?
We may not have food and water, but we have a soldering gun, wire, solar cells, and a fan.
And wine.
Let's see if we can configure these solar cells to power the fan and push the boat.
The purpose of this project was to explore principles of physics by building some solar panels using broken solar cells that we purchased online. The end goal was the powering of a small, portable fan. What this lab really explored was using alternative methods of storing and using energy. Specifically, the method of storing energy utilized in this project is called solar energy. The Earth receives an incredible amount of energy each day from the Sun in the form of electromagnetic radiation, or ER. As much energy falls on the planet in 1 hour as the total amount of energy our population uses in 1 year. That's a lot of energy. So, how can we harness this energy? One way is by using solar panels. Solar panels consist of photovoltaic cells, or PV cells. Photo, meaning light, and voltaic refers to the production of energy. So in essence, PV technology helps us create electricity using light. In this case, we are using light from the sun. It may seem surprising that solar energy can power electrical devices, but it's true. In fact, one could even use Ohm's law, V, which equals to IR, voltage and current times resistance, to figure out how much voltage, which is the force that moves an electrical current, is present in a solar panel full of PV cells. Ohm's law could also be rearranged to tell us the current and the resistance as well. How does a PV cell work? These cells have at least 2 layers of semiconductors, one that is positively charged and one that is negatively charged. When the rays of sunlight, or photons, hit the semiconductor, the electrical field across the junction between the 2 layers causes electrons to be released and therefore energy to flow. The greater the strength of the sunlight, the greater the potential for electricity. Even in cloudy weather, though, photons are making it down through the Earth's atmosphere and can still be utilized in solar energy panels. Utilizing mirrors, which we maybe should have tried in our experiments, solar panels can be made stronger from the reflection of the sun's photons off the mirrors into the voltaic cells. When successfully working, the light, or photons, that hit the solar panels is converted into electricity that can be utilized to power various electrical devices. The main benefit of solar electricity is that it is clean and does not harm the atmosphere by releasing greenhouse gases. The problem is that it is not very efficient, and the production of solar cells can harm the environment in other ways. Making the solar panels involves soldering the broken solar cells in a series circuit and using a soldering gun and insulated wire. Unfortunately, the process of just connecting the various pieces of solar cells was extremely difficult. Despite our heroic effort, we were also unable to get any one of our soldered solar panels to power the portable fan, or even a light bulb. There could have been many sources of error, including soldering faults, bad wires, or a weak circuit. As discussed earlier, we were unable to power our portable fan device using solar energy and therefore have no results. But instead of looking at the project as a complete failure, we look at it as a part of the nature of science in conducting experiments. Not everything is always going to work, and sometimes you have to start from the beginning, or even take a whole other approach on it. Nevertheless, we did learn about the process of utilizing solar energy as an alternative to batteries, coal-based, or other form of common electrical production.
I don't mind it fun living in the real world? Ain't it good being all alone? Where you from? You might be the one who's running things. Well, you can ring anybody's bell and get what you want. See, it's easy to ignore trouble when you're living in a bubble. So what are you gonna do when the world don't orbit around you? So what are you gonna do when nobody wants to fool with you? Ain't it fun living in the real world?
Oh man, we can't get the fan to work. Guess we'll just have to make SOS sign out of these.
Let's do it.
A few moments later.
Oh man, we only had enough for SO. So,
How is anyone gonna find us now?
I saw your guys' SO sign. Do you need help?
Yeah, that'd be great.